In this video, we're going to work on more solving one variable inequalities and what that means. Look at the first one. It says, is each number following the inequality a solution to the given inequality? So if you look at this, it says m is less than negative 3. So they want to know if negative 5 is less than negative 3. One way you can do this, if I go and all I want to do is substitute that in there, I have negative 5 less than negative 3. Is that true? Is negative 5 less than negative 3? Is negative 5 smaller than? Yes, it is. It is a solution. Now, another way is if I had a number line, and if we did the graphing, and I have negative 3, let's graph this for a second. This says less than. Do I use an open circle or a closed circle? You use an open because it does not have the equal sign. It is less than, like if I open this up, it makes an L, less than to the left, so I would shade to the left. Anything in the shaded area, anything in this area is a solution. So you could have negative 4, negative 4.5, negative 4.6, negative 5. Is 3 a solution to this inequality? No, it is not, because it is an open circle. The next one, what does this say? N is greater than negative 9. So if you put 6 in here for n, is 6 greater than negative 9? Yes, because 6 is positive. It is true. But let's go over here and review graphing. Okay, so if I start at negative 9, it says n is greater than negative 9. You would use an open circle. Greater than, you'll shade to the right. The last one on this page, this says y is greater than or equal to 0. So if you substitute 3 in there, I get negative 3. Is that greater than or equal to 0? Well, negative 3 is not greater than 0. That answer is no. And if you go to graph it, I go right here to where 0 is. I am going to put this time a closed circle. It is a closed circle because of this. Let's see here if I can highlight it. Because of that equal to bar right there. Now it's greater than, so I'm going to shade to the right. Here's the next one. Let's look at these one at a time. Okay, there's the first one. Pause the video and see if you can find the answer. Now in this one, it wants us to use substitution, not solving. They don't want us to solve, because one of the ways that some people do it is they go and they solve for x by subtracting 8 from each side, and they get x is less than 2. And so they look and see, are any of these, which numbers are less than 2? You can, if this was just a test, you could do it this way. What they want you to do is plug it in. So they want you to take 2 right here and put it in here for x. So I have 2 plus 8. Is that less than 10? 2 plus 8 is 10. Is 10 less than 10? No, it is not. The next one, let's put 0 in there. So I have 0 plus 8. Is that less than 10? Well, 0 plus 8 is 8. Is 8 less than 10? Yes, it is, so the answer is yes. The next one, it says negative 8. Substitute negative 8 in there. Negative 8 plus 8 is less than 10. Negative 8 plus 8 is 0. Is 0 less than 10? Yes, that is true. The next one. There's the next one. Pause the video and come back and see how you did. Again, they want you to use substitution, so I'm going to take 6 and I'm going to put it in here for x. So I have negative 3 times 6 plus 6, and they want to know if that's greater than or equal to negative 12. Well, let's see. Let me move this up. Negative 3 times 6 is negative 18. Negative 18 plus 6, is that greater than or equal to negative 12? Well, this is negative 12 greater than or equal to negative 12? Yes, it is. It's equal to each other. Try the next one. You should have done negative 3 times. This time, we're substituting in the number 9. 9 plus 6, is that greater than or equal to negative 12? Negative 3 times 9 is negative 27 plus 6, is that greater than or equal to negative 12? Negative 21, is that greater than or equal to negative 12? Be careful, that is, I know the number looks larger, but it's negative. It's farther away from 0, the negative 21 is, so it's less than. So the answer to this one is no. The last one, you should have taken negative 3 times, we're substituting in negative 6 plus 6, is that greater than or equal to negative 12? This is positive 18 plus 6, greater than or equal to negative 12. 24 is greater than or equal to negative 12, so in this case, this is true. It is yes. Okay, now on this one, I want you to solve each inequality, then graph on a number line given below. Be sure to box your final answer. Hint, solve just like equations except for when you divide or multiply by a negative. Flip the inequality sign. Well, we'll talk about what that means in just a sec. Let me move these number lines up just a tad. Okay. We're going to treat this like a regular equation, just like we've always solved, where we would add 2 to each side, and I get 2x, these cancel, is greater than 6. I'm going to divide by 2. X is greater than 3. Now to graph it, I'm going to go here, and here's 3. Now sometimes I like to put a 0 in there just for reference. Are we going to use an open circle or closed circle? It is going to be open because remember, when that's greater than or less than, it's an open circle. If it has the equal to bar on it, then it's a closed circle. This is the greater than symbol, so I'm going to shade to the right. The next one, I'm going to add 1 to each side. I get x is greater than 11. Okay, so I go here, here's 11. The 0 would be over on this side, on the left-hand side. It is an open circle because there's not an equal to. The greater than is to the right. Next, let's see here. Why don't you pause that video and do these next 2 problems and come back and see how you did. On number 3, I would go and I would subtract 2 from each side, and I get x is less than negative 7. Because you have 5 negatives and 2 negatives, that gives you 7 negatives. So I have negative 7. The 0 is to the right of it because you'd be getting more positive going to the right. I would make an open circle, and you should have shaded to the left. Number 4, you should have subtracted 5 from each side. You get negative 3x is greater than 6. Divide by negative 3. Ding, 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 whoop, whoop, right here. You divide it by a negative. Anytime you divide by a negative, you have to flip the sign. So what I mean is this is a greater than symbol. It flips over and becomes the less than. Now this is x and negative 2. So x is less than negative 2. So I have negative 2. The 0 is over here. It is again going to be an open circle, and I'm going to shade to the left. Okay, let's see here. Let me move some of these out of there. Well, actually, we'll move all this up so that you can do all of them. So you see all 4 problems. I would pause the video and come back and see how you did. Okay, on number 5, you would subtract 1 from each side. You get negative 2x is less than 4. Right here, you would divide by negative 2. Ding, 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 whoop, whoop. Okay, you can't, or you can, but when you divide by a negative, you have to do something to the sign. So instead of less than, it becomes greater than. So this is x is greater than negative 2. So the same, I guess I need to move this down. There we go. So I have negative 2. 0 is on the right-hand side. I will use an open circle and shade to the right. Number 6. Right here we have 1/3 times x. Well, you're going to multiply by the reciprocal. Well, what do I mean? I mean you flip it over and it becomes 3 over 1. And you do that to both sides. Now, by multiplying by the reciprocal, this cancels out. And I get x is greater than or equal to, this is negative 6. So right here, here's negative 6. 0 is on the right-hand side. We'll use a closed-in circle, and you're going to shade to the right. Okay. Let me move this bar up a little bit. Okay. On this next one, you would just divide by negative 5. Ding, 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 ding. Again, you're dividing by negative, so this makes the sign flip. Instead of less than or equal to, it becomes greater than or equal to. X is greater than or equal to 4. Well, we have a closed-in circle this time because of the equal to bar, and we shade to the right. Number 8, you would subtract 7 from each side. You get negative x is greater than negative 4. I'm going to divide by this number. This is a negative 1. You're dividing by a negative 1. Ding, 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 ding. Right here, the greater than symbol becomes less than. So you get x is less than 4. So now, I'll move this down just a tad. Here's 4. 0 is over here. We're going to use an open circle and shade to the right. Here's 2 more. Actually, we'll leave this on. Go ahead and do these 2 right here. Pause the video and come back and see how you did. Right here, you should have added 2 to each side. You get 2/5 x is less than or equal to negative 2. We're going to multiply by the reciprocal, so flip it over. By doing that, these cancel out, make 1. So I get x is less than or equal to. Take negative 2, parentheses 5 divided 2, multiply them together. You get negative 5. So right here I have negative 5. The 0 is on the right-hand side. It is a closed circle because it is equal to bar. That is less than. That means I shade to the left. The next one, you have a number outside the parentheses. That means you have the distributive property. So I'm going to take 3 times x and 3 times negative 2. So 3 times x is 3x. 3 times negative 2 is negative 6, is greater than 9. You're going to add 6 to each side. You get 3x is greater than 15. Divide by 3. And you get x is greater than 5. Okay, well here's 5. 0 is in relation is to the left. Now, it is an open circle because it's only the greater than symbol. The greater than means shade to the right. The next 2, there's the next 2. Pause the video, answer those, and come back and see how you did. On number 11 here, if you notice, you have x's on both sides. Well, you need to move the x's to one side and the numbers to another. It's easier if you move the x's to the left-hand side just because of the way inequalities are. So I'm going to move the 2x to the left-hand side. Now, a lot of people just try and put it over there. Remember, you have to do the opposite. So you have to subtract 2x from each side. Okay, and once you get that, oh, sorry, I had to pause here. Once you have that, I get 3x plus 8 greater than or equal to 2. So you will subtract 8 now from each side. You get 3x is less than or equal to negative 6. I'm going to divide by 3. Now, in this case right here, am I supposed to flip the sign? No, because the only reason you flip the sign is when you're dividing by a negative, is when the bottom number is a negative. So it stays the same. It is x is less than or equal to negative 2. So here I've got negative 2. There's the 0. We're going to put a closed circle because there is the equal to bar right there. Less than, I'm going to shade to the left. Number 12. There's a number outside the parentheses, so you have to do the distributive property. So you get 6x minus 12 is less than negative 12. You're going to add, you should have added 12 to each side. And this is where some people get confused, because they go, this cancels out, and then they leave it like this. Because they know that negative 12 plus 12 is 0, but they just think that they should not put anything there. Well, negative 12 plus 12 is 0. 0 is a good number. So you put 0 there. Now we divide by 6. And we get x is less than 0. So now here is 0. I'm going to put an open circle, and I'm going to shade to the left. Let's see here. Here are the next two. Right here. Pause video, see if you can figure out what the answer is. Let's see. There's the number lines. On number 13, again, we have x's on both sides. So let's move this 3x over to the left. You can't just put it there. You have to do the opposite. So you have to subtract 3x from each side. And you get 5x minus 6 is greater than 14. From here, you need to add 6 to each side. You get 5x is greater than 20. Divide by 5. And you get x is greater than 4. So here is 4. Here is the 0. It is an open circle. Because there's not an equal to bar, it is greater than, so we shade to the right. Now, if you look at number 14, this one is a compound inequality. We've got numbers on both sides, but here's the big key right here. It says 2x. I need to get x by itself. So what we will do is we'll divide everything by 2. Well, 8 divided by 2 is 4. Less than right here. These cancel out, so I get x less than or equal to 10 divided by 2 is 5. So now we should be able to graph this. I've got a 4 and I have a 5. Okay, well, on the 4, x is in between 4 and 5, but on the 4, does it equal 4? No, so it's an open circle. Now 5, it's equal to 5, so it's a closed-in dot. Now x is in between it, so you will shade in between. The next two. There's the next two. Right here we have the same type of compound inequality. Pause that video and see if you know how to do it. Right here what I'm going to go and do, it has a 3 in front of the x. So I'm going to divide everything by 3. And I get negative 2 less than or equal to x less than or equal to 4. So I'm going to put negative 2. I'm going to put 4. Well, both of them have equal to bars, so that means I'm going to have a closed-in dot, and you're going to shade in between because x is in between these numbers. Number 16. In this case, you need to put together your x's. Now, do you do the opposite? Do you just keep them the same? What do you do? Well, because they're on the same side of the equal sign, you can put them together. I have negative 4 minus 1, which is 3. x, and then you put together 7 plus 6, which is 13. You don't have to do the opposite because they're on the same side of the equation. Now, down here, the 13 is on the opposite side, so I subtract 13 from each side, and I get 3x is less than 3, divide by 3, x is less than 1. So right here I have a 1. It will be an open circle. It is less than, so I'll shade to the left.